All right, so thank you everyone. I'm David Adderman, head of Web3 investments at M31 Capital. Focus on both liquid and illiquid investing, mostly infrastructure and middleware related. A lot of compute, data, and the like, which is why I'm in the middle of a lot of Web3 AI investments. Just to start off, let's have everyone introduce themselves, who they are, and what they, who they're working for or building.
Sure, I'll go first. My name is Christian. I'm founding platform engineer at Hyperbolic. We are building a couple of things. The first layer is a peer-to-peer ecosystem and sort of decentralized peer-to-peer cloud, which is up and running. You can try it out, you can use it. And on top of that, also up and running decentralized inference. And we're currently serving all of the most popular open source AI models, vision models, audio models, LLMs, and you can try those out as well.
Hey guys, I'm Matt. I'm one of the investors at Figment Capital. We're a fund based out of New York. A small team, 4 people, been around for a couple of years now, primarily focused on investing in pre-seed stage projects in the infra space. Very glad to be here.
I'm Zhao, founder and CEO of Block. Block is actually a company about federal learning and blockchain block. So it's a technology where we keep private data local, but then still do a training in an automated way.
Hey everyone, I'm Ben, co-founder of Jensen. We're building the network for machine intelligence. Most people know us for the compute protocol that we build, which connects up machine learning capable compute devices with anyone who wants to train a machine learning model. Basically, we replace all the low-level primitives of machine learning with operations that can be performed on any device anywhere. So ML engineers and researchers kind of forget about the concept of hardware because it's just available all the time as a kind of base resource.
Awesome. Well, welcome everyone. Thank you for joining us. So we'll start with you, Ben, and Jensen. At the heart of the project is matching compute power with ML and anyone who wants to train a model. So, big picture, you can keep it high level, but how's that matching done, and how do you make it efficient in a way that's cost that it has a cost improvement over the incumbents?
Yeah, so the goal for us is to look at the really low-level bits of machine learning and then essentially just create a free market over that. So get us kind of down to the base resources as you possibly can, almost to the electricity basically, which is the kind of main actual core worldly resource that sits underneath machine learning, and then create just a global kind of unlimited size market on that resource. And in doing that, you just remove a load of the inefficiencies of the current kind of centralized markets. All of the places where a company might right now sort of carve out a moat for themselves by hoarding hardware or creating kind of regulatory barriers or something like that, because all of those things just add inefficiencies to the market and drive up prices essentially. So if you can go all the way down as kind of low level as possible and just allow anyone who is able to essentially refine electricity into a machine learning operation to trade that with somebody who wants to do a machine learning operation, then you eliminate the kind of ability to create those sort of like whirlpools of value capture where businesses are able to take away kind of value from the market. And in that way, you increase supply up to the maximum it could possibly be. A simple way of thinking about it is everyone can become a data center, where right now, if you've got a bunch of GPUs, if you've just got one GPU at home, you can't really be a data center in the sense that you can't kind of act like AWS because you need a lot of things in front of that hardware in order to actually rent it out to somebody who wants to do ML work. Whereas if you replace all of those things that AWS does with technology, you replace all of them with code, then that person with a single GPU at home actually can kind of look identical to AWS in a way. There's obviously loads of intricacies to kind of scale and things that are different between those two examples, but you level the playing field across all devices, and in doing that, you make, in our view, the fairest possible market for that core resource.
Got it. And Christian, Hyperbolic, I think that's more on the inference side of the market, although I could be wrong. But
Sure. No,
yeah, how do you can kind of explain the architecture and how that works?
Sure, yeah. So basically we have a core substratum of peer-to-peer computing. And on top of that, our first sort of reference product built on top of that is inference, right? So the core subparallel computing is what I focus on, and then a lot of our incredible AI engineers are building inference on top of that, right? So the thing I think Ben mentioned, which is really important, is you think about where all of this is coming from. It's a massive amount of engineering capital that is right now directed into centralized providers like Amazon, Azure, etc. And that capital isn't just going to switch overnight to using a decentralized protocol and spending in cryptocurrency. It would be awesome, but it's not realistic. So, to the extent that we can, and to the extent that we have, it's as I said, it's running right now. It looks and feels a lot like AWS renting an instance. Dare I say, I mean, a lot more pleasant than Amazon for anyone that's struggled through the GPU plug system. So in practice, I think decentralization comes not just from the technology, which is there, it's deployed, but it also comes from the ecosystem, the community. You think about decentralized technologies, and I think in this room, a lot of people are going to think Bitcoin and Ethereum, but just as decentralized, perhaps even more, are protocols like Git, email, those kinds of things, which are decentralized in the wild prior to Bitcoin. Those are parts of inspiration that we take as well to get decentralized in practice and in tech.
Jihao, did I pronounce that word?
Yeah.
So Flock is federated learning, so kind of crowdsource model training. Can you talk about what the advantages you feel you have versus centralized players, and where you are kind of or where Flock is today, and what are the next steps to kind of get to where you want to be?
Yeah, so I think the really cool thing about us is we do have our industry applications already. We're working with hospitals that are deploying their glucose monitoring and prediction models with us. I think back to the question that you just asked, if privacy is only just nice to have thing, it's hard to actually get a very large mass adoption on the applications. But when it becomes a must-have, for example, when it comes to some specific industries, healthcare, then you have to segregate those data. Or like finance industry, where there are walls between different teams, you can't just share those data. So for those niche use cases where you have to have kind of framework for you to do the decentralized training, that's a way to overcome all those drawbacks in the centralized training action. So yeah.
Very good. And Mads, we will. I didn't forget you. OpenAI just raised a ton of money. There's been a lot of funding in the Web 2 AI space. A lot of the top, talent. It's hard to turn down, what they're getting paid to come to Web 3 and join us. But, how does Web 3 kind of compete, longer term against these kind of, deep-pocketed investors and corporations that have a moat perhaps, and only will keep building as time goes on, or is that not right?
Yeah, I mean, actually, in the first half of 2024, there's been $35 billion poured into AI startups in the private market, and the only way that, for example, retail investors gain exposure is through mainly stocks like Nvidia, which is a $3 trillion market cap right now. I think that the way that blockchain or crypto AI projects establish a presence here is on some of the topics that we touched on here, which is around certain cost savings. If you're aggregating idle compute, in theory you can reduce some costs there, and you can give access to specific users. For example, universities that need access to specific GPUs, there's obviously issues there with latency and efficiency, verifying that you're using the actual GPU, you're actually using the H100. But I think it also pertains to other specialized use cases like privacy preserving cases, like in the healthcare sector and in the finance sector. And I think that crypto is interesting here also because of tokens. So in and it's something that's kind of maybe not touched on as much, but crypto is very good at finding ways for people to trade things that they find interesting and it creates a new capital formation for these teams to try out these different experiments. And right now, if you look at the market cap of crypto AI tokens, and if you subtract the AI adjacent tokens that aren't like specifically only AI like NEAR or an ICP, the total market cap of all those tokens is around 20 billion. That's like 40% of meme coin market cap. And smart contract platforms is like their total market cap is like 600 billion. So I think there's a lot of room for growth there and a lot of room for capital formation to push out these teams to experiment there. So yeah, I'm pretty excited to see what the future holds, and I definitely makes sense to be part of it.
Or maybe meme coins and L1s are just terribly overpriced, but I guess we'll never know. So kind of a good segue there is, and Christian and Ben, you touched on it, but looking at first principles on the cost structure, and this is really, I think, all of DeepIn. Are there really, a lot of networks will, and I think, well, I definitely know Jensen does, but I don't know if Hyperbolic will, if you marketed your cost savings, but 80-90% cheaper than centralized providers, and I think a lot of pushback to that is, well, it's subsidized by a token and you're basically just a Ponzi or whatever. Obviously, you're automating a lot of the management, the OPEX, the operating overhead, but how much cost savings can be had, and how where does it come from specifically in your eyes from a distributed network, a decentralized distributed network versus the economies of scale of AWS? I'll start with you, Christian.
Sure. Yeah, so just to paint a little bit of a picture about how supply comes into our network, which if you got a laptop, you can do it right now. You can supply, realistically, you probably want a laptop that runs like GPU and make it easy. But you can install HyperDOS, which is our distributed operating system. It creates a cluster. That cluster then jumps into our supply, and then you can set the price. Working on some nice UIs to make that clean. I don't see it as our responsibility to determine the market price of GPUs. The market's going to determine that price. The thesis is that the more GPUs enter that market, the more we make it easier for GPUs to enter that market with really, really clean single command install cluster operating systems. That is what's going to bring the price down. And we've seen it play out. We've gone to partners, they've said, yeah, we want to supply our GPUs, it's usually difficult. We say, all right, well, here's the command to do it. It installs HyperDOS, up they come, and then anyone can come and start renting those GPUs right away. So, like I said, I don't think it's our role to determine the price, but you've seen it happen over and over. If some disruptive technology comes in, makes it way, way easier to do something that was previously difficult, unlocks a whole bunch of supply that was previously stranded, that'll change the price.
Ben?
Yeah, I think Christian's absolutely right on the main point, which is basically just more competition makes a more efficient market, essentially. And a lot of a number of years ago, used to talk quite a lot about the price kind of benefit of these networks. The centralized market realistically has improved significantly in terms of competition. So a lot of the kind of supply chain constraints and the general chip supply constraints have actually alleviated in the 3+ years since we published our original white paper, which talked about these kind of big differences. So since then, there has been much more competition in the market, more chips kind of flooding the market, and the dynamics have changed significantly. But one thing that's still true is that it's still inefficient and difficult to get those GPUs connected up to people who want to do machine learning. We're actually kind of tipping over where there's a bit of a GPU glut now, where there's a large amount of these devices that are capable of doing machine learning operations, but the barrier no longer is getting the chips or something like that. The barrier is being able to connect them up and give somebody access to them, so to actually kind of sell them to somebody in the free market, essentially. So what we think is required is that generic infrastructure that just allows anyone in the world to kind of join that market as a supply side participant, and B, just makes that entire thing much more efficient. It results in the kind of clearest global market price for the resource, which is just it's just a core belief, right, that will be more efficient than the existing situation. But it's not just price that we think about when we think about decentralized compute. It's also like scale and access. And access can be a derivative of price, like some people are just priced out of the market. Somebody who has a great machine learning idea just can't pay the cost of training a model, so they can't do it. You bring price down, you give them access. It's a binary for that person rather than this kind of like price constraint, but also just actually having GPUs available that you can access. Like I said, we're in a glut of GPUs, but they're still hard to access. There's plenty of GPUs sitting in data centers that don't have any kind of mechanism for somebody to set them a task yet. Somebody needs to kind of set all of that up. Whereas if there is a generic infrastructure, just open source software you can run on that device and connect it up to a global network, suddenly it's much more freely available to other people on the kind of demand side. So that kind of access piece is crucial. And then finally, the scale piece. When you're doing modeling right now, you typically have to go and find a provider to sell you access to hardware. So I'll go to AWS and I'll lock down a certain number of GPUs for the next 3 years that they'll agree to sell me, or one of the other providers. I'm then limited to that scale unless I lock down more GPUs, and in doing that I'm putting a huge capital up front in order to do it. If you have much freer access to the devices, a freer ability to just send a task to a device at any point in time, you can elastically scale that up and down on demand. It becomes much more like serverless rather than this idea of I have to buy a bunch of GPUs and then I'm kind of putting all that capital up front, guessing my demand in the future. So price is an important one, but I think scale and access are also equally, if not more important.
Yeah, I agree with that. Jihao, incentivized federated learning makes a lot of sense to me, and when you disrupt all the incumbents with the business model, how do you expect them, or maybe you're seeing it today, but what response do you expect to see? Obviously there are big structural differences between centralized model and a decentralized model, and so what's your expectation of kind of incumbent reaction?
Yeah, I guess the biggest difference between when it comes to decentralized model or model accessibility lies essentially for these long-tail revenue sharing problems where you can't expect maybe NVIDIA wants to go to the corner shop saying I'm gonna build a model for you. That's too small niche case models, right? So they probably will focus on more the majority of the use cases. But then when it comes to those small shops who want to have their own already a model, maybe who knows one day, or some of the use cases that I mentioned about hospitals, finances, or even personal assistants, right? So all those long-tail demand, that's where I see decentralized models can be very, very helpful. They can be deployed in a safe way, and also all the contributors to that model can get their incentivization back from the usages of the end users. So I think I guess that's a very big that's a big difference, I would say, comparing to the centralized model where it's like one access for everything.
And you just mentioned a lot of interesting use cases and a lot of seemingly all these platforms are kind of general purpose and kind of enable whatever people want to build on it. And Mads, I'll throw this to you, it's your turn. But what use cases and markets or areas within Web3 AI are you most excited about, or you see the most kind of growth potential as an investor, or just someone nerding out on Web3 tech?
Yeah, for sure. I'm pretty excited about using crypto for an initial layer, whether that be to incentivize idle compute, gather that, or use that to aggregate data for people, incentivizing, like kind of like what's Kara is doing, for example, data labeling and creating, giving people incentives to do that globally at scale. And or even sharing their own personal data is interesting. And I also think that a lot of, in the future, a lot of transactions that happen on chain will probably be through agents. So ways that these agents improve the user experience and guide users through operating on chain or transacting value, I think makes a ton of sense.
Christian, and then I'll go ask you guys specific use cases maybe you're seeing or you kind of can imagine would leverage your respective platforms, either most or just in interesting ways that you've been thinking about.
Happy to jump in. So we think very low level. theoretically anything can be built on Jensen that uses machine learning operations essentially. I think most interesting to us, that piece that I mentioned on scale, because you remove any sort of scaling limits, you can kind of start to forget about the concept of scale within machine learning models, because when you have unlimited, scale can be just this on-demand capacity. So we think quite a lot about the idea of taking the concept of like mixture of experts models and kind of pathways through models at query time and saying, well, that can just be done constantly at query time at any point in time. You can do it in training, you can do it in inference. So the idea of composing models on the fly as and when you need them from a space of theoretically up to all of the devices in the world that are capable of doing machine learning operations is pretty exciting to us. And then once you've got that infrastructure that's able to be scaled in that way, you're able to create and chart new paths through it on demand. You get this almost like emulation of the internet where people could spin up their own sites, but those sites, instead of being websites, are now parameter space. They're kind of stuffing information into this really rich space that can be interrogated at will and then modularly composing it with other spaces on demand, a little bit like requesting a web page, but actually you're just pathing through all of potentially our like expert models that we've built in different areas that we know about or have data about. So probably the most exciting thing that we think about is that just progressing as a world state, us all kind of building models and then being part of this very, very modular future where the size of a model is just whichever path it takes through all of our devices and the kind of servers out there to get the richest data and returns back to us. If functionally unlimited, essentially.
Sure, yeah, I can pick up from there. I think my answer would be maybe I tend to focus a little more on day-to-day. I think I come from a background of like heavy usage of AWS, Azure, whatever in my previous lives, previous parts of my career. And that's the thing that I see happening the most in our platform right now. Again, like I don't think we can dictate how people want to use Hyperbolic, but what we've got is an evolution of the cloud from the existing centralized model to peer-to-peer. It's working, it's surviving, it's growing. We like that, and what we've seen so far is that the people that need that the most have been AI researchers, and by virtue of having access to this platform that we've built, kind of before anyone else has realized that it's up and working, like going right now and much, much cheaper than any of the other existing solutions. We've been able to build stuff and start providing through directly through our web interface for AI, through our API for AI, or white labeled elsewhere around the internet, where you have AI brokers starting to really route a lot of traffic to our inference service because the underlying model is better unit economics. So I think our approach is more letting demand be demand, whether it's running web services, whether it's running data hosting, whether it's running video streaming, or whether, as it is right now, mostly running AI because we've built it on top of it. That's kind of where we're going. I think the theoretical stuff will come, but right now I really tend to focus on serving existing demand right now and making money on that, making the system grow, and continuing to be more and more decentralized.
Question for all of you, you can go in whatever order, but one of the advantages of distributed, decentralized architecture, infrastructure, is it's permissionless. And so, to the extent you can verify that, you can connect it to smart contracts. And I think there definitely is a cost savings play here. There's definitely a access to more data and better incentives. But do you see longer term the main end user of your platforms? Sorry, Mads, but you don't have a platform. But being human or smart contracts or other AI agents, but either way, basically this is something that a centralized entity could never offer because it's permission. So I don't know if you've thought about it. I spend a lot of my time thinking about it, but would love to hear how you think through that problem, and whoever wants to go first.
Yeah, I can go first. Permissions. I think permissions is a very good add-on to the decentralized. Well, for the blockchain to adding on to the traditional AI infrastructure. Because you can think of, for example, you can think of block as a just like a training framework, just like PyTorch. Okay, in traditional world, we use PyTorch to build models. The difference maybe into using Flock is you're still using something like PyTorch, but then the only difference is you need to put your wallet address there and it's taking the train, right? And that's where, because of this, economic effect behind and or getting a game theory behind, then you will have those incentives and then you will have those selection mechanism to make sure that people are not playing evil. Then you can make the network actually very open because the whole blockchain behind it can help you do the do the audit and do the computation between the each to make sure that the network is actually active. So yeah, that's how and also the reason in the very beginning why we do Flock in decentralized ways is because of the help of the blockchain technology, especially for proof of stakes, right? You can make machine learning run in a decentralized fashion.
Yeah, we think very strongly about the kind of machine economy that you alluded to. The idea that right now most of the economic interactions that happen in the world are like humans. Smart contracts you can see as just being autonomous agents. They now have the ability to have funds and have addresses and kind of interact in a closed environment in an identical way to a human, where the actions that they can take are the same as kind of a human can take. At the same time, we look at machine learning and say the ability for autonomy that we're getting from new machine learning techniques is huge. Can we kind of level both of those things up at the same time? So increase the environment that's available to potential agents at the same time as increasing the capability of those agents. And the next big thing to bring to that kind of smart contract ability to financially interact environment, in our view, is to interact with the core resources that run those agents. So if you're a smart contract, put your head in the kind of the shoes of a smart contract, you're able to buy certain singular assets on the blockchain, but you're not able to buy the things that fuel you. You can't buy compute. So we'd like to make it so that you can buy compute. And then in the future, you could buy data. You could buy access to human knowledge in order to label samples so that you can improve. So gradually what we're doing there is just increasing the available actions for an autonomous agent that doesn't require it to be bottlenecked by a human. Because right now, we don't really think about that too much. Like if I'm training an ML model, the fact that I have to interact with Amazon and go through a KYC process, it's annoying, but it's not that big a deal. An autonomous agent just can't do that. It needs to have a purely programmatic access to the resources it needs. And that's what the kind of combination of crypto and blockchain, crypto and AI gives us. It gives us the ability to bring those resources under a completely kind of programmatic paradigm and give agents access to that. And we think once you do that, you see this just explosion of automation that can happen as we just offload more and more of what we do day to day in knowledge work to agents that work on our behalf.
Very cool. Anything to add?
Sure. I think that's the biggest thing about moving into a crypto cloud. That is the thing. Every top-level researcher, just to focus on AI, has run into this issue at one point or another. If you want to get a whole bunch of GPUs, you kind of got to jump out of your editor, which no one likes to do when they're in that zone. So very, very core to it is, can you make automated payments?
Okay, now it's investor talk time. So Mads, what do you, and I guess I'll answer this as well, but what do you value the most when you're looking at the Web3 AI space? Pretty open-ended question.
Yeah, I think I kind of touched on that in my last answer. I think it's projects that are taking this more specialized approach to building these different applications, like say for example in the privacy preserving space where you can input your personal data and own that model. And I think obviously as an early stage investor, the thing that we value the most is an incredible team. So that's obviously first and foremost the thing that we look for.
I guess I'll answer it, and I alluded to it, but I think time's up. So I guess I can't answer this. All right. Secret stays with me. I guess I can't answer it, but basically, what can you do? Structural differences in Web3. What does that enable that you can't do in Web2? And this is for my Web3 thesis in general. But in AI, I think a lot of the things that we talked about, automation, permissionlessness, kind of having agents like buying compute and what that does with composability and compute, I think there will be a lot of functionality that Amazon, Google, and the rest will not be able to do. And so a lot of people talk about the ideology of decentralization and all that. I think Web3 will win because of functionality.